So, what if our cities, the very buildings we live and work in, could actually heal the planet instead of harming it? It sounds like something out of a science fiction movie, right? But the solution might not be in some futuristic, high tech lab. It might be in the biology that's been all around us all along. Today, we're going to dig into how we can build a better future by learning from nature's oldest secrets.
All right, let's just get right into it. Take a look around you. Chances are you're not far from something made of concrete. It is, quite literally, the foundation of our modern world. But it has this massive hidden cost. Making cement, which is basically the glue that holds concrete together, pumps a huge amount of CO2 into the atmosphere. So much, in fact, that CO2 levels are higher now than they've been in the last 800,000 years. We've built our entire civilization on a material that's actively fueling our biggest environmental crisis.
But what if we could just flip that script? What if the problem itself could actually be the solution?
And this is where things get really, really cool. This brings us to a revolutionary idea called bioconcrete. It's a way to not just shrink our carbon footprint, but to actively turn our buildings into carbon-sucking machines. That's right, I said living bacteria. The idea is as brilliant as it is simple. You mix these special little microorganisms right into the concrete. And what do? They literally breathe in carbon dioxide from the air. They grab it, they lock it away, and they turn a harmful pollutant into a part of the building's actual structure. So this isn't just a less bad version of concrete. We're talking about a completely new kind of material. So who are these tiny construction workers? Well, they're a special kind of bacteria from the Bacillus genus. And these little guys are masters of a very special kind of alchemy. They can take a gas, CO2, and turn it into a solid mineral. They are the living, breathing engine that makes this whole thing possible. Now, I know it sounds a little bit like magic, but it's all grounded in some really elegant biology. So how in the world do these bacteria pull off this trick? Well, let's take a look at the science of turning gas into stone. The secret weapon here is an enzyme called carbonic anhydrase, or Ca for short. Now think of this enzyme as a biological supercharger. See, CO2 can turn into a mineral in water all on its own, but it takes forever. What these bacteria do is produce this Ca enzyme, which speeds up that whole reaction by, get this, up to 1,000,000 times. It is biological machinery at its absolute finest. And here you can see how it works on a molecular level. The enzyme basically acts like a tiny, perfect machine. It zeroes in on a CO2 molecule, grabs it, and kicks off a chemical reaction that turns it into a solid mineral, locking that carbon away where it can't do any harm. These bacteria have evolved the perfect tool for the job. So what we have is a concrete that literally cleans the air. That is a massive, massive win for the environment. But, it leads to the biggest, most important question of all. That's great and all, but is it actually strong enough? Can you really build a skyscraper with this stuff? And this chart just says it all. This shows head-to-head strength tests. Okay, so the blue line, that's your standard everyday concrete. The red line is our new bacterial concrete. And whether you're talking about compressive strength, how much you can squeeze it, or flexural strength, how much you can bend it, the bioconcrete doesn't just keep up, it blows the old stuff out of the water. And this is the real kicker. This isn't a trade-off. You're not giving up performance to be more sustainable. It's the opposite. The very same biological process that captures carbon also makes the concrete stronger. As the bacteria create these little mineral deposits, they fill in all the microscopic cracks and pores in the concrete, making the whole thing denser and way more durable. We get a greener material that is fundamentally a better material.
Okay, so a stronger, greener concrete that eats CO2 for breakfast. It sounds just about perfect, doesn't it? Almost too good to be true. So, you know it's coming. What's the catch? As with any new technology, it comes down to the practical stuff.
And right now, the biggest hurdle is, you guessed it, cost. Early estimates suggest that making bioconcrete at a large scale would be somewhere between 7 and 28% more expensive than what we use now. And for a global industry built on tight margins, that's a pretty significant barrier to entry. Now, you might be thinking, hey, what about other green concretes, like the ones that use fly ash? And that's a really good point. Using fly ash definitely helps because it replaces some of the cement. But think about where it comes from. It's a byproduct of burning coal. As we, hopefully, move away from coal power, that supply of fly ash is just going to dry up. It's a short-term fix that's tied to an old, dirty industry. Bioconcrete, on the other hand, is a true long-term solution. It's sustainable, and it doesn't just reduce emissions. It actively removes carbon from the atmosphere. And, this whole idea of partnering with biology, it's just so much bigger than concrete. It really points to a massive shift in how we think about solving problems.
There's actually a name for this. It's called biomimicry. And it's this beautiful idea that we should look to the natural world for solutions to our biggest challenges. For centuries, our approach has been to dominate nature with engineering. But what if, instead, we could just learn from its incredibly efficient, time-tested systems?
And this shift is happening everywhere you look. We're seeing building facades designed to grow moss that literally scrubs the air clean. We're finding microbes that can eat millions of tons of toxic gases. We're rediscovering ancient materials like fast-growing hemp that can be used for everything from paper to building materials while locking up carbon. It's a total reimagining of what technology can even be. I mean, when you really stop and think about it, nature has had the ultimate R&D budget. 3.8 billion years of evolution, of trial and error. The blueprints for a sustainable world, they're already out there. They've been perfected over eons. The real question isn't whether they work. The question is, are we finally smart enough to start using them?